video, we're going to be talking about heat and work and learning how to calculate heat and work so that we can calculate internal energy for processes and explain more how internal energy is classified as a state function. So heat and work are how energy is exchanged. And so when we talk about the change in energy, this delta E, the change in internal energy from its initial state to final state, that change in energy is occurring through work and heat that are exchanged between the system and the surroundings. The signs of the heat and work tell us which direction things are flowing. So if we have a positive value for heat and work, that means that this system is gaining energy. So if we have a positive value for heat, that means the system is gaining thermal energy from the surroundings. And if we have a positive sign for work, that means that the system is having work done on it. And so overall, your delta E for your system is positive because heat is flowing into your system overall. If you have negative values, then that means the opposite. Negative values for heat mean you have your system losing heat to the surroundings. Negative values mean that your system is doing work on the surroundings. And if your delta E system is negative overall, it means you're having a net loss of energy out of your system. You really need to shrink yourself down and imagine yourself in the system so that you can kind of conceptualize whether you are experiencing a loss of heat or you are experiencing a gain of heat. Are you doing work or are you having work done on you? So you kind of have to shrink yourself down and think from the perspective of the system so that you can get your signs of heat and work assigned correctly. We know that your E of system is going to be equal to your negative E of surroundings because energy is conserved. So anything lost by the system is gained by the surroundings. So if we look at this pool table where the white ball is defined as the system and the purple ball and the table and all that stuff is defined as the surroundings, then this white ball initially starts out with 5 joules of energy, and then it's traveling along this table, and in the process, due to friction and whatnot, it loses 0.5 joules of energy. And then it collides with the purple ball and transfers 4.5 joules of energy to the purple ball. After that collision, it transferred the rest of its energy to the purple ball, and so its energy after the collision is 0. So the delta E for this process is equal to its final, which is 0 joules, minus its initial, which is 5 joules. And that's going to be equal to a net loss of 5.0 joules. We can also think of delta E as the sum of the Q plus W. Why is it not writing well? So delta E is also equal to Q plus W. Since it's losing heat here, the 0.5 is actually negative. And so it's equal to negative 0.5 joules. And then since it's bumping into the ball and losing this energy here, it's doing work on the purple ball. And so we are adding a negative 4.5 joules. And so we get negative 5.0 joules by adding up the work and the heat And also we can get 5.0 joules by taking the final minus the initial. So there's two different ways that we can calculate this change in energy for the system. Let me label this system so we don't get confused. Here's another situation with the similar situation, but now that the table is a lot rougher. So in this scenario, we are again starting off with our white ball is equal to 5 joules. This time it's losing 3 joules to the table due to heat loss, and then it is only going to be able to transfer 2 joules. So once again, our delta E is equal to Q plus W. And so that means our heat lost here, the white ball is losing heat, and so that is 3.0 joules in negative. It's a negative sign there because it's losing heat. And then we are going to be adding negative 2 joules because the white ball is doing work on the purple ball. And when you do work, when the system does work, it is a negative work value. And so that works out to a negative delta E of 5.0 joules. That's supposed to be a 5. My tablet's not working well. Okay. And so we can see from this example that it's this, since the ball had the same initial kinetic energy value and the same final kinetic energy value, then delta E was the same in both this example and the previous example. And that means that energy, this internal energy, was a state function because it didn't matter which path we took to get there, we had the same change in energy that occurred. So here is that summary. So the delta E is a state function. It only depended on the velocity of the ball, the mass of the ball, how much energy did the ball have initially, and how much energy did the ball have in its final state. It started off with 5, it ended with 0 joules, and so it was the same change in energy no matter what combination of heat and work were used. But heat and work always added up to the change in energy. Let's do an example problem. This problem says a cylinder and piston assembly, defined as the system, is warmed by an external flame. The contents of the cylinder expand, doing work on the surroundings. So we are doing work on the surroundings. Anytime we're doing work on the surroundings, that tells us that our work is negative. By pushing the piston outward against external pressure. If the system absorbs 500 kilojoules of heat, so absorb means that we're going to have a positive heat value, and we are doing work. So since we are doing work, it's telling us that that's going to be negative 488 joules. What is the value of delta E? So we start off with our equation. It's always good to just write out the equation without any numbers in it. So that's Q plus W. And then you have to, we've already kind of thought about the signage here, but it is important to interpret the word problem and to assign the signs of each so that you can get your signs correct. And so we said that that's a positive heat value. And so I'm just going to go ahead and write positive 559. Since this is a positive value, you don't actually have to write the positive sign, but you can go ahead and continue to write it if it helps you. And then we have a negative work value. So I'm going to write plus negative 488. Why is my tablet not writing well? And so if we calculate this, that is 559. When you add a negative, it's like subtracting. And so that's 559 minus 488. And so that is 71 joules. And so we still have a net gain in internal energy because we do have a positive value here. And so our delta E here is positive 71 joules, indicating that our system is overall gaining energy. Let's do a conceptual practice problem. Based on each statement, decide whether each quantity would have a positive or negative sign. So if a can of soda is put into an ice chest, the system is the soda. What sign is heat? And then go ahead and pause the video and think about each of these, and then unpause the video when you are ready to kind of verify. All right, so if the soda is put into an ice chest, then heat is going to flow from the soda to the ice because it always flows from warmer to colder. So the system is the soda, and so Q should be negative here because the soda is going to be losing heat. Next, it says a step stool is pushed across the ground. The system is the stool. What sign is work? So we said work is a force applied over a distance. So if we are pushing the stool, we are doing work on the stool. And so that means that the work value for the stool is positive. Work is being done on the system. If we put an ice cube inside a glass of water, it melts. And so the system is the ice cube. What sign is the heat? Heat needs to flow into the ice cube in order to melt it. And so that's an endothermic process. Heat flows into the ice cube. And so that's going to be a positive value. Next, we say a parent pushes a child on a swing. The parent is the system. What sign is work? Well, the parent's doing a lot of work here, pushing that child around on the swing. And so the parent is doing work. And so that is a negative value for work. Here's another practice problem. It says if the burning of fuel in a potato cannon performs this many joules of work on the potato and produces this much heat, what is delta E for burning the fuel? And so that is the system. So go ahead and pause the video here, work this out, unpause the video when you're ready to check yourself. All right, so the delta E here is going to be for the fuel because that is the subject of our sentence. And so the burning of the fuel does this much work. And so that is a negative value for work. It's doing the work. Next, it says it produces this much heat. And so that is, it's giving up that much heat. And so we got our Q plus W. And so that's going to be negative 1422 joules. Oh my gosh, I'm going to have to restart my tablet. That's awful. And then that's going to be plus negative 855 joules. And so that's negative 1422 minus 855, and that's negative 2277. That's supposed to be a 2, folks. Ugh. What is up with my tablet today? Overall, we can say that this does make sense because a combustion reaction like this is very exothermic. You should all know that fire releases a lot of heat. And so the system, the fuel, is losing that energy to the surroundings, and then we're observing it come off. So the negative sign here does make sense.